Hello, welcome to Microeconomics with Ntato. This session is on production. We will start with short-run production followed by long-run production. A production function indicates the highest output that a firm can produce for every specified combination of inputs. The equation for production function is output is a function of capital and labor. In the short run, capital is fixed and labor is variable. And in the long run, both capital and labor are variable. So capital is variable in the long run as the firm has accumulated profits to purchase new capital. Let us look at the short-run production and determine how labor contributes to the production process. The two equations that show the contribution of labor to the production function are average product and marginal product. Average product is output per unit of labor input. That is, it is equal to total output divided by labor, and marginal product of labor is the additional output produced as the labor input is increased by 1 unit. That is, as the firm employs one extra employee, what additional output does that employee contribute? It's equal marginal product of labor equals to change in total output divided by change in labor. And let us look at the example that follows. In this example, we are given the amount of labor, and it's from 0 to 6, the amount of capital, and as we have already determined, in the short run, capital is fixed, and that is why it's 25 all the way. And total output, you can see that as labor increases, total output increases. Now we need to calculate the average product of labor and the marginal product of labor. We said the average product of labor equals to a change equals to total output divided by labor. So total output when labor is 0, total output is 0, and therefore that is 0. Total output when labor is 1, total output is 15, that's 15 divided by 1, that is 15. Total output when labor is 2 is 40, so that is 40 divided by 2, and that gives us 20. And 69 divided by 3, it gives us 23. 96 divided by 4 is 24. 120 divided by labor of 5, that is also 24. 138 divided by 6, that is 23. Marginal product, we said, is equal to change in output divided by change in labor. So when labor is 0, output is 0, and therefore that is 0. When labor changes and it's 1, that is the change in labor is 1, and change in output is 15, because 15 minus 0 is 15. So 15 divided by 1, it gives us 15. And when labor changes to 2, we say 2 minus 1, that gives us 1. And then we say 40 less 15. And the additional output that an extra 1 unit of labor produces then is 25. And then when labor is 3, it's 3 minus 2, it's 1. So when it comes to labor, it's easy because it's increasing in increments of 1. So the change is 1. So when labor is 3, the total output is 69. So what is the change in total output? It's 69 less 40, and that gives us 29 divided by 1, and that is 29. And 96 less 69 is 27, divide by 1, it's 27. 120 less 96, that is 24, but divide by 1, it's 24. And a change when labor is 6, it's 138 less 120, divide by 6 minus 5, that gives us 18, divide by 1, and that is 18. When we look at the marginal product of labor, we will see that as labor increases from 1 to 3, the marginal product of labor is also increasing from 15, 25 to 29. But when labor gets to 4, it starts decreasing. It's at 27, and then it goes to 24 and 18. This we call the law of diminishing marginal returns. This is a principle that as the use of an input increases with other inputs fixed, so as labor increases with capital fixed, the resulting additions to output will eventually decrease. And I want to put this here because this description is usually asked in exams. So as labor increases with capital fixed, workers will start sharing tools, waiting in queues, or getting in each other's way. Therefore, hiring more labor ends up becoming inefficient. Let us now look at the long-run production. So we said in the long run, we had that both capital and labor are variable. So managers use isoquants to decide on all the possible combination of capital and labor that yield the same output. These three isoquants are called the isoquant map, and they are used to describe a production function. Output increases as we move from Q1 to Q2 to Q3. With two inputs that can be varied, a manager will want to consider substituting one input for another, and we call this marginal rate of technical substitution. So this marginal rate of technical substitution equals to a change in capital divided by a change in labor. And the answer is always positive. So this is actually the slope of the isoquant. As capital decreases, we increase labor. But this, you can see that there is a diminishing marginal rate of technical substitution, because as we decrease capital and increase labor, you can see that it's diminishing compared to the first one. And even the last one, it shows that it's diminishing marginal rate of technical substitution. And this tells us that the productivity of any one input is limited. Marginal rate of technical substitution is closely related to marginal product of labor and marginal product of capital. So we can equate this, that marginal rate of technical substitution equals to change in capital over change in capital of labor equals to marginal product of labor divided by marginal product of capital. Let us look at this example. In this example, the marginal product of labor in the production of computer chips is 50 chips per hour. The marginal rate of technical substitution of hours of labor for hours of machine capital is a quarter. What is the marginal product of capital? So remember that the marginal rate of technical substitution equals to change in capital divided by change in labor equals to marginal product of labor divided by marginal product of capital. In this example here, we are given the marginal product of labor, and it's 50 chips. And we are given the marginal rate of technical substitution, and it's a quarter. So what we need to calculate is the marginal product of capital. So let us substitute the numbers into the equation. So the marginal rate of technical substitution, it's a quarter, which is the same as 0.25, equals to marginal product of labor, which we are given, which is 50, divided by marginal product of capital. Marginal product of capital. That is marginal product of capital equals to 50 divided by 0.25. And this gives us 200. Thank you for watching. I hope you understand short run and long run production. Remember to like, subscribe, and comment.